is here right now.
Okay.
But if you shoot it here, by the time your missile gets here, the airplane will be over here.
Okay.
And you can't just send it after. You can't just send the missile after the airplane because it can't turn very well because on the Schmetterling, it couldn't go very far, and the wings, the only thing that turned was the wings. The engines didn't turn, so it turned very slowly. So you have to. So you shoot here where the aircraft's gonna be. And then for smaller angles, theta is roughly equal to sine theta.
Okay, what is theta though?
This angle.
Well, what is that angle?
It's the angle between the line that goes to where the aircraft is now and where the aircraft is going to be. So you're trying, and you need to find angle theta because that's what shows you like where to shoot your missile. So sine theta, which is the same as theta for small angles, is opposite over hypotenuse. Oh, and this right here. Oh, but it only works if there's a right angle. But since none of these are right angles, you need to extend it out to here to see. So sine theta would be opposite over hypotenuse, which is CB over range future here. But you don't know your range future, but these are the things you know. You know your velocity of your missile, VP, the P is for projectile, velocity of target. This is time. You don't actually know time, but since it's going to cancel out, you act like you know time.
Time of what?
The time of like the airplane flight, how long it takes for the airplane to get from here to here, and how long the missile takes to hit the airplane here.
Okay.
And then you also know your omega. It looks like W, but it's not. It's a Greek letter, and it means it's the angular velocity, which means how many angles per second it rotates.
How many degrees?
Yeah,
or how many radians?
Yeah, how many degrees per second it rotates. So
what rotates?
The telescope and the missile, because the missile goes at the same angle that the telescope moves. But and the telescope shows you where the airplanes go. And
What is why does the telescope move? What do you mean with the telescope move? Why does it move?
Because the telescope
has to track
the enemy airplane here. And so you also know your range, which is from here to here. So since velocity times time equals to distance, your VP times T will give you this, your range future. So sine theta equals line segment CB over VP times T. But you don't actually know what CB is. So what you do is this is an arc right here, of like a circle, and you can find the arc by measuring theta in radians instead of degrees times your range. Well, actually, okay. So the regular, the range is from here to here, but the range prime is from here all the way to here. So you need to use your range prime because your arc is over here.
So you're using the r prime as your radius, right?
Right. So
Okay.
so CB. Oh, and the arc is about the same as CB. So CB is roughly equal to theta times range.
Actually, r prime.
R prime, yeah, R prime. That's right. And it doesn't need to be exact because you can just send it close to the enemy aircraft and then blow it up so that the shards of the missile rip the enemy aircraft apart. So then.
So do you ask Yaya, does he understand what you're talking about?
So do you understand so far?
Not everything in detail.
Oh, like what?
Sine theta is this side divided by this side, right?
Right.
This side is
VP times T.
VP
Because
times
velocity
T.
times time equals
Oh,
distance.
okay.
That's the velocity of the missile. VP
Yeah.
is stand for velocity of projectile.
So is there anything else you don't understand?
Can you explain one more time the arc? How did you find the length of the arc?
You find the length of the arc by measuring theta in radians and then multiplying it by the r prime, which is from
here to here?
Yeah, that's the radius of a circle. Okay, so he's trying to draw a circle here.
Yeah.
Okay.